Okay, I'll do 23 here, and then I'll do 24 and 25 in one video together. I want to rewrite this table here, so I'm going to rewrite this, give myself a lot more space to work with. So I have A, B, C. And I'll have 1, 2, 3. Okay, so we've got 60, 90, 48, 57, 89, 91, 55, 98, 84. I'll go over a little bit. I didn't give myself quite enough space to do what I needed to do here. Yeah, I didn't plan this out well enough, y'all. Okay. Yeah. A little bit more. Okay. Okay, cool. So, first thing we're asked to do, compute the row totals. Here's my rows. I need the totals for the rows. Column totals. I need the totals for the column, and I need the grand total. Let's use green. So I'm going to add up these rows to get my row totals, add up the columns to get my column totals, etc., etc. Let's turn this thing on. Oops. $172, $277, $223. Okay, those are my row totals. Column totals. Let's get those things. Oh, yeah. $198, $237. Now, when I add up my column totals on my row totals on my column totals, I should get the same value as my grand total, right? So 198 plus 2 times 237, 172, oops, 172 plus 277 plus 223, 672. That's my grand total. Okay, so I've gotten step 1 complete. Row totals, column total, and the grand total. All right, so the grand total is in that color. Okay, so now compute the value of the chi-square test statistic. If I go to the table, right, the chi-square test statistic is that chi-square, we know it, chi-squared equals the sum of the observed minus the expected squared over the expected, right? We know it, but let's write that. Chi-squared equals the sum of the observed minus the expected squared divided by the expected. But see, I only have the observed frequencies here. I don't have any expected frequencies. And the table doesn't give me a formula for it, does it? Nope. So I'm just going to have to tell you this formula. Expected value E is the row total times the column total divided by the total divided by the grand total. And this is expected value for every single cell. You have to do this 9 times for this problem. Yeah? I'm going to do that in red. So I need the row total times the column total divided by the grand total. Okay? Let's do it. So for this cell, for 60, right? The row total is 172. The column total is 198. Multiply those, divide by 672. Row total times the column total divided by the big total. 50.678. Let's use... How many decimal places do I want to use? Let's use one decimal place because... Let's use two. Let's use 50.68. And this is the... That was 50.68, right? This is the expected value. Sometimes you see it written in parentheses if you don't have multiple colors, but since I have the colors, I might as well use it, right? For this cell here, row total times column total divided by total. There's a quicker way to do this. I will show it to you, but I want to show you this process too. 277 times 198 divided by 672. 81.62. Again, these are the expected values here. For 223 times 198. So the combinations of numbers will be different for each cell, right? 223 times 1. Well, except for these two, because these two values are the same. Divided by 672, 65.71. Here, 172 times 237. 172 times 237 divided by 672. 60.66. Now, the funny thing is, this will be the same too because it's 172 times 237. So these values will be the same. Oh, gosh, I did drop it. Got it. Okay, next one, 277 times 237 divided by 672, 97.69. And the same here. A lot of numbers, right? 223 times 237 divided by 672, 78.65. If you want to check, if you add up the expected as well, you'll get the same totals. I'll just do one just to check. 50.68 plus 81.62 plus 65.71. That's going to give me that 198.01 because of rounding. Okay, so now I can do this chi-square formula business and do my observed minus my expected and sum them all up and get there, which is a lot, right? Now I can actually use, at this point I can actually use, well, let's quit out of here. Let's clear the memory. Clear all the lists. I don't know if I want to show you. Let me think about this. Okay, I'll show you two ways. I'll show this the way that we've done the others now, right? Where we put all the observed values in one list, all the expected values in another list. Because at this point now, all I'm doing is I'm just summing these, right? So let's do it that way first. And then I'll show you the other way I'll show you is without having to do all these calculations, without calculating the expected values. I'll show you a way to do that in the calculator as well. So the first, let's enter all the observed values: 60, 90, 48, 57, 89, 91, 55, 98, 84. Okay, and now my expected values, the corresponding ones: 50.68, 81.62, 65.71, 60.66, 97.69, 78.65, 60.66, 97.69, 78.65. Okay. And then just like before, quit out of there. Second list, doing list math, and we want the sum. So now I'm just putting this formula in. The sum of the observed values are in L1 minus the expected values are in L2, squaring that, divided by L2. 11.17 is my chi-squared value. Okay, 11.17 is my chi-squared. Okay, so another way I can do that from the beginning, right? This is a way that I can get this 11.17 from the top without even doing all of this. So I'm not even gonna, I'm working right here. Just zoom in with me right here, right? Right here. Let me clear all this because this is profound. Not really, but okay. So what I want to do is I want to enter this contingency table as a matrix. If I enter this as a matrix, I can jump right to chi-squared. How do I do that? Here's how I do that. See matrix right there? That's what I'm entering. So second, this x raised to the -1, that's my matrix. Now, I want to edit the first matrix. I want to edit it. I want to edit it. I want to edit it. So this is, remember, rows by columns, right? So this is a 3-row by 3-column matrix. So 3 rows by 3 columns. And it gives me that matrix. I'm just entering these values in. 60. It goes over to the right. 57. 55, 90, 89, 98, 48, 91, 84. Those are my values in my contingency table. And now the calculator is going to do all of this here. Do all of these calculations. How? Go to stat. This is in effect the test statistics. So I'm going over the tests. And then I go down to the chi-squared test. Let us see. Since this is chi-squared, that's where I go, the chi-squared test. So I input the values in the matrix, go over to chi-squared test. The observed values are in A. The expected values, you'll calculate that. I'm not putting those in. Hit calculate. There's our chi-squared, 11.17. It even tells us our degrees of freedom are 4. We know that, right? Because 3 by 3, 3 minus 1 is 2, 3 minus 1 is 2, 2 times 2 is 4. It even gives us the p-value. If you use that p-value analysis, it gives you the p-value. If p is less than or equal to alpha, reject the null hypothesis. If p is greater than alpha, do not reject the null hypothesis. And we're going to use this in number 24 and 25. Now 24 and 25, I'm not doing this again. 24 and 25, maybe I'll do it for the first one, but not for the second one. I'll do it once for the first one, and then we'll go from there.